His penis is barely even human.
I'm trying to think. We could do congruency because this is
That'd be so. This would be
this is minus
complementary.
90. Yeah,
Yeah,
this is
that's
minus 90 from
complementary
that one.
to.
I almost
So that'd be
wonder if these two triangles are identical. Oh,
These two triangles have to be identical
yeah.
why?
because the side
Uh,
angle, angle, side angle.
Oh, that's true.
They
Like
share
these
a
angles, the
side and the
side.
angles. Yeah,
Okay, yeah, that makes sense.
they nest two angles that nest a congruent side are
Okay,
congruent
so
triangles.
then we can.
And then the top and bottom triangles are also congruent because they share three angles.
yeah. Well, they also share a side, the outer edge
Uh,
of the. Well, I guess are we? Oh yeah, this. I was gonna say, do we presume that this is a square, but it's
Yeah.
titled a square.
Square.
Square. Well, that's an important question to
I
ask.
think it would be really hard if it was a rectangle. I don't know if we'd actually be able to solve this.
Well, not even a rectangle. Like, oh, it's a parallelogram where it's like 91 degrees and 89.
Yeah, an angle is 1, 2, which means.
No,
Did you
angle,
change
angle,
the code?
angle is similarity, not congruency.
Yeah, because it can
These are only
be.
identical because they share an outside side. So these
Oh, okay.
sides are.
How do I change my pen color, Carl?
There's like
Oh,
the
right.
yeah, the little I don't know.
You can't
What are
put
those things
don't
called?
put those in black though, Leaf, because
Oh,
or just add a third one,
Okay, yeah, third.
because otherwise they're the same as the interior ones.
Yeah.
Which
Okay,
means
so we
that
marked that a square is a
this,
square.
which means that those,
It's an
those two are
important thing to acknowledge. It's geometry. What is a square?
those two are the same as
What
each
is a
other. Those
square?
two are the same as each other.
Am I supposed to have pre-existing knowledge of geometry to take geometry?
Yes.
Fuck, man, I missed my shapes and colors class.
What am I
What does
gonna
that
do?
tell us? We just set a value equal to x?
Honestly, I was
don't
just
know what
thinking
any of
of
these.
calling the side length 1. Because it doesn't
Yeah,
really
just
matter.
call it
Yeah.
1.
It's just fraction.
Yeah.
X equal to 1.
Yeah, that's fine. As I say, you're just gonna divide through at the end anyways, so.
Yeah, it's gonna be.
So when do I get to bring in cosine law?
I don't know if
I don't
we. I
think,
don't know if we need it.
do we need laws of
No.
cosines and
Okay,
sines?
so
I don't think.
okay, so these are the same. These are the same. I'm gonna start labeling them. I
Yeah.
think we
Yeah.
can say that. I'm gonna.
We should be able to say with certainty
color.
that
So like
change to like something
these
that
are the same, and then probably.
Yeah. This is
Yeah.
also a symmetrical shape. We just know
Right.
that because it's
That I added.
because like these since it has these identical triangles, and then if you make like a plane of symmetry like here,
Yeah.
it's
Right.
or
Leaf,
it,
you can
like
make a plane of symmetry from corner to corner. They literally
yeah.
gave you one.
Well, yes, that too, but that's a harder one to intuit, and also it needs to be rotated about that, like it doesn't flip across. Well,
Alternate interior angles.
Yep.
whatever.
So we need.
So we can say
We're going through a
that.
percentage.
Yeah, we just need a percentage. Okay, wait.
Okay, well we know the length of. We know the length. We know
Oh,
the
yes,
length of the
this, like,
double.
this
The
side
given
is
double.
1.
Yeah, the
Yeah.
given double dash lines are root 2 over 4. We know that
Yeah.
from rules of
Rules of nature.
Rules of nature.
4.
Wait, these ones are root 2 over 4?
Yeah. All
The
of
given
those.
congruent sides. Yep.
What?
You know
Oh,
the
wait, oh yeah,
areas.
because it's a square.
Yeah.
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 Times
Then you just
1
divide it by 4. That makes sense.
times, and then we need this height h, which is here, which we get from.
Wait, so if we know the diagonal is square root of 2, no, it's not complete yet.
I mean, it's since this shape is though, we just need to figure out the size of these two small triangles. Which
We also need the size of the big triangles.
Yeah, what if I...
Well, oh yeah. Well, sorry, I meant small as in the these interior shapes.
wonder if this diagonal is a... intersects the center, like how the other one does. Because then we can,
I
if
think
it
they both
does,
have to.
yeah,
They
if
both
it
have
does, then
to
we can
because
divide
it's a
these things into separate triangles, and then
Oh yeah,
yeah, that's
Mm,
smart. We
yeah.
can definitely do that. Trying to
It's
figure out
smart.
this the height here is we can get from Pythagoras. But we don't do we want to do that? Can we
Well,
use the law of
you, well,
we know
we
this
don't
is
actually
we
know
know
any of
this
the
is
angles. Is there? Can
we
we
know
find
this
like a
one.
the number of the angle?
We know this one. And then we can use what is it, adjacent over hypotenuse? Oh no, that doesn't work because it's a yeah, no, that doesn't work.
Yeah, we don't know the length of the base.
Right.
Well, like on that smaller triangle.
Yeah.
Um,
So how can we get the
does
height so that we get the area? Maybe we don't need it.
does this problem require a lot of cosines?
I mean, maybe. Um, we just need to find like a numerical angle, and I think it'll start kind of collapsing because we know what everything is relative to each other already.
What is law of cosines? Is that right?
Law of cosines is if you
Oh,
know
there's a square
it's like
root.
the opposite or something.
Yeah.
Uh, love
But you need to
cos.
know you need to know an angle and two sides then.
Yeah,
Yeah.
or
Well,
the opposite, two angles
yeah.
on the
So,
side or something like that. All right.
No, you need an angle and two sides.
well,
Right. Yeah, yeah, yeah.
we well no we have a triangle where we know two sides. It's the big triangle. We have square root
Oh,
2/4
right.
and side 1.
Oh, so you're saying can we use well, but we don't know
S-
any of the
We don't know an
angles.
angle though.
Yeah, yeah.
Mm,
Law of cosines would give us this side here, which we
yeah.
don't really.
Um,
I mean, we might need it, but yeah, it's
I mean, if we can find out the
Can
if we can find out this length here, we
is it
can
minus?
find out an angle.
yeah.
We can also look at law of sines because that's also an option
Yep.
for sure.
Yeah,
See,
it's just we're running into a problem where we just don't know the actual value of any of these angles.
law of sines.
Wait, don't we? We should. I feel like we should be able to know this angle if this is a diagonal. I feel
Oh,
like
yeah, no, yeah, that's a diagonal, so it has to be 45.
Which one? Oh, this one.
Uh,
this is a
the double
diagonal,
dash.
so this has to be
Oh,
45. This has to be
they're both 40.
45.
They're both 45. You're right. So
Yeah,
that's how
this,
we get H. We get
Okay,
yeah,
H just from
sweet. I think everything just kind of collapses on after that.
yeah. Once you figure out that one angle, we can do everything from there.
Single
So then
line.
we have the area of these. They're both 1/8.
They're 1/8. Okay, sick. Then we just gotta find the last two. Oh wait,
These
we can
lines
use law
are
of cosines now to find this side length. Um,
which side length?
hold on, I was in black, drawing on black. We can use to find this side length.
Oh, yeah.
Yeah, so if we find this side length with the law of cosines, we can then relate this angle with this side length and this angle with this side length in the law of sines, and then we have an
Then we'd
angle
have
in this
for
triangle.
that one.
Yeah.
I think we might be able to simplify this actually, because we don't need this side length, right? We just want this angle,
Um, which one?
right?
Yeah, yeah,
Yeah,
we
yeah.
only want this
We
angle.
want this angle. So we know we can already just relate then, right? Because we know because we can just solve for this angle, can't we?
But we
Oh
only
no, we
have
can't. No, you're right.
this
We can't.
angle.
Yeah, you're right. We can't yet. No, you're right. Okay. Sorry.
So no, you're you're good.
Fuck you.
I'm gonna call this B for now.
Yep.
So then B
Eighths, I guess.
is 0.790569. And I'll just keep the number in this calculator.
Really?
Yeah,
Should be 5/8,
5/8. Hold on.
I think. Give me 1 sec. Oh no, I didn't square root it. It'd be square root of 5/8.
Okay, this is, oh shit.
Sorry. Yeah, sorry. Yeah, that's the right
Okay.
number. I apologize.
No, you're good. Just making sure I'm doing my math right. 63.4349 degrees. We'll just say 63.4.
Yeah.
So that's this angle.
Okay.
Okay.
So we have an angle and we have an angle and a side
Yeah.
length in this triangle. We will need one more thing.
Yes.
Either a side or either a length or a angle measurement.
Actually, we know how long this diagonal is, and we have B.
Mhm.
And we have this length here. So we can do a law of cosines to get this angle, and which is this angle, and then use 180 minus both of these angles to get this one.
What? This angle is not the same as this angle. Guaranteed, I don't think.
Oh, why not? Wouldn't this angle and this angle be the same, assuming this diagonal goes through the center?
Yeah, those two would be the same.
Yeah. Oh, well, yeah, I guess I misspoke. So these two aren't equal, but they'll add up to 180. So I guess we
Yeah,
would
with
still
that
have to
angle.
find this angle.
Right. So we'd have to find that one as well.
Are these two lines parallel?
I mean,
They have to be, don't
I think
they?
I think they technically have to be, yeah.
Yeah. So
So
then
it's a
we can,
quadrilateral.
yeah, so we can make this angle and this angle the same.
Yes. Yep.
And then since this angle and this angle are the same, and we know the two angles, this one and this one, we can find out what this angle is, and then I think we can calculate this side length.
If we know, yeah, if we have two angles on a side, we can
Yeah, because
calculate that side length.
we have this side, this angle, and this angle.
You can just do math then. I mean, we know this one's 45. We know this one is 63, and so 180 minus those two
Yep.
would be this angle, and then 90 minus that would be this angle.
Okay, hold on. So 180 minus 45 minus
63.4.
oops.
Whatever that value is.
18.43.
That's this one. So yeah, then we just do law of sines.
Yep. Okay, we get 0.79056, which is the B number we calculated before. Wait, that's interesting.
That shouldn't be possible. That would mean those lines are the same length, which is clearly not true.
Yeah.
Do you have the answer to this problem?
No.
Oh.
I might be
If
able
we
to find
simply
it,
assume
but
that we're correct.
if we simply assume we're correct.
That is interesting that that's how the math works out. The only thing I can assume is that the lines aren't parallel then, but they must be.
Yeah, they kind of have to be.
I mean,
Okay, so this is the same angle here.
Interesting that it
then-
works out like
wait,
that.
wait. This one here. What do you math that to be?
18.43. Or wait, no. It was that angle is 71.56.
71 point.
It has to be less
Yeah.
than 45.
Yeah, it does. It's true.
Wait,
And this angle here
Yeah,
needs
this
to be
one
greater
has to
than
be.
90.
This one has to be greater than 90.
why?
Because
Because
look at it. It's obtuse.
Because look at it.
Well, I mean, I know that that's not like,
we know
typically
one's
geometry
45
problem.
and one's less than 45, so that one has to be greater than 90 for sure.
Yeah, that's the rigorous
why?
explanation.
Why doesn't the math work out that way?
So it's 180, right? Is
Interior
is
sum
this
of a triangle.
yeah, is this not
Yeah.
45?
It has to be 45.
That has to be 45, yeah.
Definitional to the square, like diagonal.
What the fuck, dude? This is so weird.
what do we do?
Did we use law of
Average
use-
geometry problem.
Did we use law of
Degradation.
Did we use law of cosines wrong?
Maybe.
Law of cosines is
1 squared plus b squared minus. We know cosine is 45.
Do we do wait?
I don't think we used it wrong.
Like, did we use? So if we're so we were solving for that obtuse angle, right?
Yeah. Yeah, that's what x is.
Yeah. So we put C in the right. C it'd be 1 is equal to all that if because that's C.
Yeah.
So 1 is equal to da 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 da. Well, wait. Did we?
So that would be 2. Wait, what? No, z is equal to 2/8, which is a 1/4. Oh, which means this is a 45/45. What?
Wait, what?
Wait,
Well,
how's that
oh wait,
possible? Wait,
no,
It has
that
to
no,
be.
has to
It
be.
it
has.
has
It has to be.
Yeah.
because
It
it's
has to
90,
be.
45, 45.
Yeah, it has to be. Which means this is h.
That's h. Um
So
then yeah,
means
then,
this is one.
this number is not 63 degrees. I don't know what I did wrong.
This is 0.75.
What's 0.75?
This.
Oh.
That.
Well, yeah.
So
so
Pythagorean theorem tells us that b squared should be the square root of 0.75 squared plus 0.25 squared,
Okay, hold on.
which is exactly the number we got.
Oh, really?
Yeah,
so
0.7905694415.
all right, so we're good on
Oh.
B then.
Yeah, so then B's correct. Okay, good.
B is
So
right.
wait, now that
I
we
mean,
have 3 sides, can't we?
we could do this too.
How about we just recalculate that 63-degree angle?
Yeah.
Yeah, we know that this part is 45. We know that half of it, like less than half is 45.
See if I just did my math wrong. B is
I literally checked.
0.79. It's just inverse sine of sine 45 over b.
Yeah.
Yeah.
Unless you're reciprocal. It's
I'm a
not
bit
side over angle, is
confused.
it?
Um,
No. That's so strange that that's not working out. Why does law of sines
Do
not
you
work?
have sine in radians?
yeah, no,
Nah.
it's in degrees. I checked. So I was like,
Degrees.
that's the
Okay.
first thing. That's the first culprit.
I
Hold on, I'm
That
gonna
is so
paste in what I
strange. Yeah, go ahead.
entered.
Yeah, that looks right to me.
X
And that's
being
for
the
x.
X being the interior, that interior angle. We know. Can we solve for
Oh,
that?
wait. Does inverse sine, what's the domain on inverse sine? Doesn't it only do
Son of a
Oh,
bitch.
you have to.
Would have to add
Yeah, you'd have to add
it,
90 to
something.
that. Yeah, you'd have to
so
add
it'd be
90.
153.
Because it goes from negative
Negative
90 to
pi over,
positive.
yeah,
Yeah, it goes from negative 90 to positive 90.
yeah.
That's the domain of sine.
Nice.
No, you
Good
take.
catch.
Would you add 90?
Yeah, because the sine of 153 and the sine of 63 are the same thing. Same value.
Yes, that makes sense.
No,
Wait, 153.
because 63 is like here on the unit
Or wait,
circle.
no, it's not. It's 180
It's here.
minus 63.
Yeah, it's 180 minus to get this because we want
Okay, okay.
Yeah.
this angle. Because
So
153
yeah,
is over here.
it's 117.
Yeah.
Which that makes more sense. Yeah, looking at the actual visual.
Yep. Yep.
Okay, and that's 116.5. So let me things that isn't the image.
Okay, so now we know that this angle is this. We take minus 116.56 degrees. There we go. So now we can take 180 minus 45 minus that.
71.56.
So this, and then we take 90 minus that.
Or yeah.
So yeah, it's 71.56.
Okay.
Which then
That's
we can
side
come in
length.
here.
Man, it's great that I had this all as variables because now that it changes, I don't have to redo the math. That new side length should be 0.2635.
Carl, it didn't work.
Oh, you're gonna wanna like hit the mouse and then like select it,
Oh,
and then you can hit delete because because
okay.
before it would select the image and it would then delete the image, but now
Got it.
that's locked, we're good. So
Okay, so what is that value?
0.2635.
Okay. So we have two side lengths and an angle. Now we need an area, which is 1/2 base times height. So of course, the only side we don't have is the base. But we can use law of cosines to get it.
Yeah, you're right. I'm just gonna erase the old one.
Just make sure we note that this is not that. It is 117 or 16. Whoa.
Whoa, whoa, whoa.
Whoa. Back it up.
I'm gonna call this this C.
S-
So C is
Okay.
yeah. You can just use law of science to find that height, right?
No.
No?
We need one of the angles first. This one
Oh,
or this one.
all right. Get
And
your
then we can
calculators out.
And then we can use cosine, the right triangle laws. So
Yeah.
we know that sine of
Well,
116.56.
let's see. Well, I mean, we have all of the lengths, right? So we could.
Yep.
Oh yeah, you then use law of sine.
Yep. So we have this is over c is equal to sine of the unknown angle that we want. What phi? Ah! Divided by
Ah!
one of those side lengths. Let's say
Is the
root
canvas
2.
static for you? Like if I move it, does that change things?
Yeah, it does.
Oh, okay, my bad.
4. So that would give us this this angle down here. God damn it, you motherfucker. That would give us this angle here. Which is fine, because then we can just use
Dude,
Pythagorean.
what is this schizo post drawing we have here?
So theta.
The Nephilim cabal at the Denny's down the street from me.
Sine of that value divided by 0.52703. Is that a reasonable number? Yeah, I guess. Okay, times root 2 over 4. And then we'll take the inverse sine of that.
It's like
It's like
it's like a
so
16th or
weird.
something. It's like just like a perfectly round fraction.
It's usually how they make them work out.
7 degrees. So that's this angle, which is good. And then we'll just use sine. So just take sine of phi, which will be equal to opposite, which is our height, which we're going to call h2, divided by that 0.2 number. 2635, I think. Right? Does that sound right, Carl?
Does what sound right?
0.2635
For
is
the
this side here.
Yeah, so 0.2635 is this side length.
Yeah, okay. So that's opposite over, that's the hypotenuse of our little mini right triangle there. So it's opposite over hypotenuse. So take sine of that times 0.2635. You get a height of 0.1581, which you can plug in down here. What was that? 0.52703? So we get an area of this. 6.
I'm gonna scroll down a little bit.
Yeah, that's fine. So the area, what fraction of the square is shaded? Is going to be 1 minus 2/8 minus 0.8332. Oh, wait. There we go.
It's that number. Okay, hold on.
Whatever that number is.
1 minus 2 over 8, 1 over 4. Minus 0.08.
It's like 2/3-ish, I think.
It's
right?
2/3. It's 2/3.
It's 2/3. Well, there you go.
Oh, Carl, you're welcome. It's 2/3.
So what is 0.00?
I feel like there has to be a nicer way of doing this one.
I don't
There
know.
definitely is.
We got it though. 2/3.
I
It's got to be what it is.
well, yeah, I mean, yeah, 2/3 is the answer, obviously. Just because that's a nice fraction and not like, oh, it came out to be like 0.71227.
Right.
So yeah, 2/3 is probably the answer. I'm just trying to think if there's like a more elegant way of finding anything here.
If we actually approximate it to be a circle and we do an integral here at 0 to pi or whatever the fuck.
I mean, it is just a four-cornered circle, right? Like,
Yeah.
if you added
Oh,
more, if you added more points, it would do this.
Well, I think if you're on a not, if you're on like a non-flat plane square,
Oh
I know you
god.
can make I know you can make a 5-pointed square on some planes
Yeah,
or on like a specific plane.
An airplane.
an
Yeah.
airplane.
Yeah, because you're fucking high.